So, what if the dust between the stars wasn't just dead matter? What if it was all part of some vast interstellar network? Today, we're diving into a really mind bending new scientific paper that's proposing exactly that, a whole new framework for how information could be processed on a cosmic scale. Now, I know it sounds wild, but as we're about to see, it's actually rigorously grounded in physics we already know. Right off the bat, the paper hits you with this huge, provocative question. And yeah, it sounds like pure science fiction. I get it. But before you write it off, the authors are really quick to define what they mean and what they don't mean.
And this right here is the most crucial point to get. We are not talking about consciousness. We're not talking about aliens or any kind of feeling, thinking being. The paper uses words like cognition and hive mind as metaphors, right? It's a way to describe a huge, spread out physical system that can sense, process, and maybe even store information. It's all about patterns, not personality.
Okay, so how could a system like that even possibly work? Well, the mechanism they propose isn't just pulled out of thin air. Turns out it's a quantum effect that nature is already using right here on Earth. Just think about migratory birds for a second. How do they navigate thousands of miles with such insane precision? Well, a leading theory is that they can literally see the Earth's magnetic field. They have a tiny biological quantum compass built right into their eyes. And this isn't just speculation. It's a super active area of real scientific research. The little engine that makes that bird compass work is called the radical pair mechanism, or RPM for short. At its heart, it's a special type of chemistry that is just exquisitely sensitive. It allows certain chemical reactions to get nudged one way or another by magnetic fields that are so unbelievably weak, they'd be totally invisible to any normal chemical process. Now, what's so wild here is the difference in scale. Standard chemistry is all about brute force. Heat, pressure, strong chemical bonds. But this quantum spin chemistry, it's all about subtlety. It can react to magnetic whispers, these tiny little fluctuations down in the nanotesla range. And that sensitivity, that's the key to this whole cosmic idea. So if birds can use this quantum trick to find their way around the Earth, how could the universe use it on a cosmic scale? Well, the paper argues that you only need a few key ingredients to build this thing out across our entire solar system. It's basically a three-part recipe. First, you need the sensors. In this case, interstellar dust grains that have little magnetic nanoparticles inside them, stuff like magnetite. Second, you need a signal, the weak, slowly shifting magnetic fields that are just drifting through space. And third, you need a container, a bounded area like the heliopause, which is basically the bubble where the sun's influence finally gives way to interstellar space. So you put all that together, and you get the core idea. You have trillions upon trillions of tiny dust grains, each one acting like a microscopic quantum compass, all floating inside a defined region and all responding to the same faint magnetic signals from space. It's not a single brain. Think of it more like an incredibly vast, super low-power sensor network. Okay, so that's the theory, but how on earth could you possibly test it? I mean, if this cosmic network actually exists, what kind of signature would it leave behind? What would we even be looking for? The paper suggests we shouldn't be looking for a signal like a radio wave. Instead, we should be hunting for a kind of ghostly pattern that sticks around over time. In the world of data analysis, this is called topological memory. Essentially, you're looking for complex shapes like loops or voids, which are technically called Betty cycles, that hold themselves together for way, way longer than random noise ever should. Let me give you an analogy.
This is a brilliant way to picture it. Random puffs of smoke just dissipate, right? They're gone in a second. But a smoke ring, that's a structure. It has a topology. It has that hole in the middle, and that makes it stable and lets it persist. That's what scientists would be looking for in the data from space, the cosmic equivalent of smoke rings that tell us there's an underlying process at work, not just random noise.
And here's maybe the best part. We might not even need to build new telescopes for this. The paper argues these ghostly patterns could already be hiding in public data archives from missions like IBEX, which has been mapping the edge of our solar system for years. They could be in maps of solar light or in low-frequency radio images of the sky. The data might already be sitting there, just waiting for someone to analyze it in the right way. Now look, this all sounds incredibly speculative, I know. But what really gives this hypothesis its scientific weight is the author's relentless focus on rigorous, falsifiable testing. This isn't just some fun thought experiment. It's a proposal for actual, real-world experiments.
The authors built their entire idea around a principle called design to falsify. This is the absolute gold standard of good science. See, they're not just looking for evidence to prove they're right. They have specifically designed a series of clean, pass-fail tests with the goal of trying to prove themselves wrong.
And this is their biggest, most important rule, their line in the sand. Before anyone spends a single second combing through space data for these patterns, the core mechanism has to be demonstrated on a lab bench first. This lab-first rule is completely non-negotiable.
So it all comes down to this number. The lab experiment has a really clear quantitative goal. They're going to create a cloud of magnetic dust, hit it with some incredibly weak magnetic fields, and then measure the response. For the whole hypothesis to move forward, the signal-to-noise ratio, the SNR, has to be at least 3. That means the signal they detect must be 3 times stronger than the random background noise. If it's not, the paper says the entire cosmic search is a non-starter. Game over.
But what if it works? What if they pass that lab test? And then, against all odds, they actually find those persistent topological patterns in space? I mean, what would that even mean for us?
Well, one of the most elegant things about this hypothesis is how the same basic idea works at every single scale. This table shows the direct parallels. The grains out in space are this special dust. In the lab, they're tiny iron microfillers. The cosmic driver is a subtle rhythm in sunlight. In the lab, it's a weak geomagnetic pulse. And the memory, what we're looking for, is the same in both places, those persistent loops. This direct mapping from the cosmos right down to a lab bench is what makes the idea so powerful and testable.
And the implications? They would be absolutely profound. We could be looking at a whole new type of super efficient analog dust computing. We might be able to use the dust between stars as a giant passive sensor for the environment out there. And it would give SETI, the search for extraterrestrial intelligence, a completely new playbook. Forget listening for radio pings. Start looking for strange, complex patterns woven into the very fabric of space itself.
But again, the paper ends with a critical dose of scientific discipline. It's so important to remember this. Even if we found these complex patterns, it does not mean we found a conscious being. As this quote hammers home, we would have found topological intelligence, a measurable complexity in a physical pattern. That is fundamentally different from biological consciousness, which is a subjective, internal experience. It's the difference between seeing a complex sculpture and knowing the mind of the sculpture.
And that leaves us with this final, tantalizing question. This hypothesis gives us a rigorous, testable way to look for a totally new kind of information in the cosmos. If, after all the lab tests and all the controls, we do find these persistent, non-random patterns etched into the edge of our solar system, it might not be a mind, but it would be a message. And the question would then become, what is the universe trying to tell us?